Welcome students. This particular lecture will be discussing about continuation on standards. So we have defined what is a standard, need for standard, and how we have fixed standards for different quantities, how we have fixed a standard for length, how we have fixed standard for weight, we have discussed. So now we get into the topic of relating those standards with measurement. So yes, I have fixed a length as 1 meter. I have fixed this is 1 meter. But what's the use of that particular object kept in Paris if it is not able to assist me in measuring my day-to-day activities? So what I have to do for that? You have to actually create an object that is measurable or that is able to measure your day-to-day objects. So hence, need for different standards arises. So as you can see, there are different types of standards: primary standard, secondary standard, tertiary standard, and working standards. So primary standard is nothing but standard which is kept in acceptable standard which is singular throughout the world. So that standard which is kept someplace in the international measuring areas, that is in Paris, that is the primary standard. So primary standards are nothing but standards preserved under most careful conditions. So these are not directly used for measurement, but they are used once in every 10 or 20 years for calibrating a standard. For example, International Prototype Meter or Imperial Standard Yard. So those standards are kept very careful in very well maintained conditions in order to maintain its integrity. They are just used once in every 10 or 20 years for calibration of secondary standards. So those are not directly used for measurements. So we discussed exhaustively about this length standard as well as weight standards. So they are just kept in some place, locked away, preserved perfectly in order to calibrate over a period of time. So then comes the secondary standards. So these secondary standards are somewhat less accurate than the primary standards. Only reason being they are kept in less secure environments. They are same exact replica of those primary standards, but they may be kept in less exposed conditions because they have to be more accessible than the primary standard. For example, every country will have secondary standards. In India, there may be one secondary standard which may be kept in National Physics Laboratory. That standard is used for calibrating every other standard throughout the country. So that is a secondary standard. Secondary standard may be available in every other countries and they may be used for calibrating the lesser standards. So they are close copies of the primary standard. So they are maintained in National Physics Laboratory. They are the ultimate reference for measuring quantities. If you have to check your measuring instrument, then you ultimate measuring quantity is the secondary standard. Similar to your courts, if you are applying in a district court, then you go for appeal in a high court. And if again you have to appeal, you can go for Supreme Court. So similarly, like the Supreme Court, the supreme calibrating instrument in any country would be the secondary standard. So next standards are tertiary standards. So tertiary standards are standards which are kept in some more regions of the country. So they are more accessible than the primary and secondary standards, but they are close replica of the primary and secondary standards. They are more accessible. For example, each tertiary standard may be kept in every other state. So they may be used for calibrating the next standard. For example, if you take weight scale, in the olden days, you are having the weight scale and there will be weight bars. So those bars will be calibrated every year in your district metrology office. So they will put a seal there in the back by calibrating it with the known standard. So those standards may be called as tertiary standards. So far, we have seen about the primary standard, secondary standard, and tertiary standards. These standards are not directly used for measurement. They are just kept in some place for calibration purpose only. So now comes the important standard, which is working standard. So these working standards are the tools which we use in our day-to-day life for everyday activity. For example, you take your vernier caliper, you take your micrometer, you take your slip gauge, you take your ruler. These are called as working standards because they are used actually for measuring. And they may be less accurate than the primary, secondary, and tertiary standards, and they may be of low cost compared to those standards because they have to be widely available to the public for usage. Hence, it should be low in cost as well as accurate. Accuracy should also matter, but cost plays a major role here. Then comes the advanced standards, line standards, end standards, wavelength standards. So I discussed about the krypton, wavelength of krypton. So that is actually the standard which is now used because light is more accurate. So as you can see, krypton 86, which is used to define the meter, which is 1 meter is that much wavelength of krypton 86. So that is how we measure length now in order to provide more accurate values. So if you understood this lecture, we discussed about standards and need for standards. Standards is particularly needed in order to maintain accuracy and same value throughout the world. So hope you understood the lecture on this unit 1. We will meet again on the lecture series on unit 2. Thank you, students. So if you have any queries, feel free to contact me. Thank you.